Welcome to Assignment 3 video tutorial. In this tutorial I will show you how to identify or discover entities based on a case study, and then how to build an ERD diagram based on the entities that you identify. So this is all about designing ERD models that would support a particular database. But before we go into the practical aspects of discovering entities and designing ERD models, I would like to revisit some theory from our lectures. So discovering entities basically means identifying things about which you need to store data. So giving a particular case study or a particular scenario or a problem that you have at work, you need to identify those entities, meaning you need to list all the things about which you need to store data, meaning the things that are relevant for a particular scenario or business purpose. Okay. So how do you do that? Well, in real life, you typically, as a system analyst, you conduct interviews or joint requirements planning sessions. Now, interviews are typically one-on-one sessions where you ask people questions about, what they do in their work, what kind of information or data they need to store, something that would support their processes or their current work. So based on those questions, you identify or discover entities. Now, joint requirements planning, or JRP, it's a distinct methodology for soliciting, for identifying user requirements, and there are a lot of specific methods, artifacts, and roles, that are outlined by this methodology. But at the most basic level, JRP means a group interview. So instead of meeting with people one-on-one, you have like a group meeting. So as I said, in interviews or JRP sessions, you ask users to identify things about which they would like to capture, store, and produce information. This is like a very high-level goal that all of your questions need to target. Also, you can do archival research. You can study existing forums, files, reports, documents. So based on those documents, you will identify what are the things that people already storing information about in this hard copy or written format. Also, if we're talking about electronic forms, then the individual fields in those forms will tell you about the specific variables or data points that you need to store data about. In any case, like regardless of whether you're looking at interview transcripts or secondary data sources, you scan those use case narratives for nouns. Basically, you scan those answers of transcribed answers of your users, or you scan those documents for certain nouns that would tell you that this is something about which you need to store data. Now, there are also the so-called automated case tools that do reverse engineering. In other words, they can look at existing files and databases, and based on their independent analysis or automated analysis, they can discover those entities and even discover keys and relationships among those entities. So those are like some general approaches to entity discovery. In a way, there's not much to talk about here, because here we're talking about something that is closer to art, not to science. In other words, how do you go about writing a good book, or how do you go about drawing a good drawing, or painting a beautiful oil painting, right? There's no straight answer to that. I mean, there are some methodologies that people follow, but it's really something that is fuzzy and something that depends on the specific scenario, okay? But nevertheless, that's what you do. Now, when it comes to assignment 3, the case is provided to you in the form of interview notes. When system analysts conduct interviews or JRP, typically to save some time, instead of transcribing everything, they would take notes. So those notes would look something like this. So this comes from your textbook, and you can find this case on page 11. Now, when you start reading this case, you discover that this case is about libraries. So you're working as a system analyst for a library, for a local, let's say, county library. And what you're trying to do, you're trying to design a database that would support operations of this library. So you talk to your town librarian, and based on this conversation, you make the following notes. Okay. So those notes will be used for entity discovery. What you need to do, you need to scan through those items one by one, and try to identify nouns in those items that would tell you that those are the things that we need to store data about. So for example, when you read point number 1, it says any resident of the town can get a library card simply by asking for one. The library considers each card holder a member of the library. Okay. Now, when I read this first point, it kind of tells me that there are two things about which we need to store data. Number one, we need to store data about residents or members, library members. I think if you call them residents, it's a bit confusing, because by resident we mean somebody who lives in a particular town or city, and not necessarily someone who has a library card, who is a library patron, right? So we're going to store information about members or residents, and then we're going to store information about their cards, because you want to keep track of cards, because some cards they expire, right? Some cards are lost, so to keep track, you want to separately store information about cards, okay? So again, this is what entity discovery is. You read this text, and based on that you discover two nouns that indicate that you need to store information about two things: residents or members, and also about cards, okay? Now, when it comes to a specific assignment, this is what I'm asking you to do in part one. I'm trying to ask you to discover entities, okay? Don't worry if it's not perfect, but just try to brainstorm, read this case right here, and try to identify all the entities that will be on your diagram. So don't worry about their relationships, but make sure you identify primary keys for each entity. And for each entity that you identify, you need to create a separate table. So let's say the first thing that we identified was member. So library member, right? And here provide like a short 1 or 2 sentence description of what this entity is all about. So I'll put stores information about library members, okay? And here just brainstorm about some attributes and also data types of each attribute. I don't require like a specific number of attributes, but people keep asking me, well, so how many attributes do you need to have in an entity? And I would say like around 5, something around 5. Again, don't forget to mark each entity as a primary key, and I'll show you how in a second. So for example, here you'll write member ID as your primary key. Here we're going to have some other, let's say member first name. Look at this naming convention. First of all, I don't leave spaces, and I think it's a good practice because some databases like Microsoft Access have a slight problem with naming variables with separate words. It's not prohibited, but there's like a technical issue that you need to keep in mind. Basically you need to, when you operate those attributes, you need to put them in square brackets to tell Microsoft Access that this is one variable, right? If you do it something like this. And some people forget about it, and it's a big mess. So no spaces. I think it's a good practice. And by the way, Microsoft Access is not case sensitive, I believe. So this is just for visual convenience for you to quickly read the name of this attribute. And then the other convention that I'm using when it comes to naming those attributes, I always start with the entity name. So this entity is called member, so I always put member first name, member middle name, let's say member last name, and here I would put member date of birth, okay? You can add, of course, you can add other ones. For example, you can add member phone number, then insert rows below member address. And address can be a compound attribute that consists of street address, house number, city, state, zip code, and so forth, okay? By the way, you'll see from the case down the road that you do need those attributes. And here specify attribute type. For example, member ID will be integer or number. Member first name would be text, and the same thing for last name and middle name. Member date of birth will be data type. Just use like the data types that are listed here. Although in Microsoft Access, the software that we'll be using later on, they have a bit different names for those data types. So yeah, put integer. I think that's how they call it in Microsoft Access. Here it's called number, so you can just put number or integer. So let's use the same convention. Yeah, phone number. By the way, phone number is more like a text because it may have parentheses and probably not some certain formattings for formatting marks. Member address will probably be a text, although it contains both text and street number. So basically brainstorm about entities and their attributes. So you can also quickly copy this table and create another table called card. So obviously in this entity you will store information about cards issued to members, okay? And here you may have such names as, I'll just delete those, one second. So here you have card ID as a primary key. Here you'll have card name. Let's say how member name appears on the card. It can be different from a full legal name, let's say, right? Then you can have card issue date. Again, note it starts with card, and it will be date. And here you may have card expiration date, and the data type is date. So brainstorm about all the entities and create a table for each entity with a list of attributes. Now make sure you mark each primary key like this in your table. No need to mark any foreign keys. Okay, so this is entity discovery, and again, if you keep reading through this case, you'll discover other entities. For example, the librarian wants to be able to contact members by telephone and by email. So that kind of tells you that the member entity needs to have an attribute called member phone number or member address, so that library members can be contacted by phone or by paper mail, snail mail. Okay, so it says also a parent and a child might have the same first and last name, live at the same address and share a phone. That kind of tells you that there may be a lot of duplication in names and addresses, so to uniquely identify each member you may want to have an attribute called member ID. So even if you have two people with the same name, same date of birth, let's say same address, then still for identification purposes you can use their IDs, and those IDs will be unique. Okay, so I'll leave it at this point. So as you go through those items, you'll discover many other entities. Okay, what I'll talk about next, I'll talk about the second part, and this should be table 2. Yeah, I'll talk about the second part of your assignment, which is creating your ERD diagram. Now it says you need to use Glyphy.com. You don't have to use Glyphy.com. In fact, I've been using Glyphy.com for a number of years, but they keep changing their pricing policy. Like it used to be free, meaning free, you could really use it for free. Nowadays, like they're playing tricks where it's kind of free, but if you want to save diagrams, you need to pay, you need to subscribe to their service. So you don't have to, most likely you end up not using Glyphy. Now, one software that is widely used for creating ERD diagram is Microsoft Visio, or creating any kind of diagram. If you have Microsoft Visio, make sure you add, like there's an option to add those drawing tools for crowfoot notation. So you'll have to go to database and you'll see crowfoot notation elements. Okay. I'm sure if you go to YouTube and you look you search for creating ERD diagrams in Visio, you'll find a tutorial on that. What I'll show you a different tool, and this tool is among the many competitors that sprung up over the last few years. So this tool is really identical to the capabilities, and the link is provided right here. I just showed you, right? You need to click here. It's really identical to Glyphy.com. It's also identical to Microsoft Visio. The only substantial difference is that it's an online tool, and actually it's quite useful because what you can do, you can save everything online and you can collaborate online. You can add several users so that you can collaborate on creating one ERD diagram. However, it's a bit problematic because typically you need to have a full subscription for that. So what I will do, I'll create a database. I'll create a diagram for our database, and for now I'll save it to our device. Although you can use Dropbox or Google Drive. Okay, so I'll create a new diagram, just blank diagram. Okay, the first thing I will do, I will reorient this page into landscape format, because usually it's easier to do a diagram. In my opinion, it's easier to draw ERD diagrams using that landscape format. And this is the tab that you need right here, entity relationships. There are so many conventions, there are those UML standards that tell you how to draw those ERD diagrams. Let's stick to the same kind of visual convention that we had in our slides, okay? So we'll be using only this box. So this box is a table or an entity. So we already identified two tables. We identified member table and card table. And for those tables, we'll create entities. Again, a bit of theory. I'd like to go back to our theoretical material. Again, how do you create an ERD diagram? That's a very open-ended, fuzzy question, because again, we're dealing with something that is called design science. It's something that is much closer to art than to science. But the following approach can be generally recommended. You can start with the context data model. Context data model looks something like this. So you only have entities and their relationships. Okay. Once you figure out the context model, you create a sketch of your ERD diagram. You can start adding keys, primary and foreign keys. So your diagram will look something like that. So here you only have entities and their primary and foreign keys. Now, again, going back to the theory, remember that foreign keys are inserted into the child entity. So remember this rule that we covered before, right? And then after you're done with the key-based model, you create a full attributed data model. Now, full attributed data model would look something like this. So not only you have entities, you have relationships, you have foreign primary keys, and you have all other relevant attributes. And then at the end, you normalize data model, but that's something that is covered separately in one of our lectures. So once you create a fully attributed data model, you normalize it, you improve it. So this is the general approach. Okay, so using this tool, this is what I will do. I'll just create like a context data model, and then I'll add primary and foreign keys. I'll start doing that, and then I'll let you figure out other relevant attributes if you want to have them. So we have so by double clicking here, you name it as a member, and then you go back to your table, and we have member ID as the primary key. And for now, that's it. I'm not going to add any other attributes. I'll leave it blank. Then we have another attribute called card, right? Again, card has card ID. Again, don't forget to mark it as a primary key, and I'll leave it at that. I'm not going to specify any other attributes. Now, what is the relationship? What is the cardinality between members and cards? Now, one member may have 0 or 1 card. Let's say it's a new member. We just entered information, and we haven't made a request to issue a card. So it's 0 many cards, and 1 card is issued to exactly 1 member. So therefore, you need to find a cardinality line that looks like what you need. So here we have 2 sticks means exactly 1. Right, because you cannot have a card for it says mandatory to many, right? You cannot have like a card that has a blank name. It just doesn't make any sense to issue a card like that. So it will be 1 on this side and 0 many on that side. So actually we need this one, right? This line. So you see I clicked on it, or you can just drag it. So 1 card is for exactly 1 member. However, member can have 0 many cards. Let's say some cards will be expired, and I'll delete this one. Okay. So let's continue reading the case if you don't mind. Okay, let's read item number 2. So the librarian wants to be able to contact members. Okay, she calls members when books are overdue and request materials become available. I'm just gonna jump forward a little bit. You see, like the way you know that books are overdue is from a table that contains information about book checkouts. So you see, when you want to link people to members to specific books, it will be a many-to-many relationship, because one book can be checked out by many members, and one member can check out many books. So there will be an associated entity called book checkout. So whenever like a member, let's say named John, checks out a book, you will create an entry there. Okay. Maybe I'll diagram that. But you see, like when it comes to this part of notifying somebody about anniversary or about when books are due, you don't have to worry about that, because this is something that's related to application software. In other words, as long as you have somebody's date of birth and you already have it here, right? You specify it here. Or as long as you know the book checkout date, then you can calculate whether the book is due or overdue or not. But again, you will do it using some kind of script. It's not really, it's something that is not related to a database. Okay. So yeah, I'm jumping forward a little bit, and maybe I'll reflect those thoughts on our diagram. Okay, let's go to. So we identified those we identified those attributes and we put them on the table here, but not on the table, because I'll only create. We didn't put those attributes on our diagram because I will create only a key-based model. Okay, let's go to now item number 3. It says the librarian tries to keep track of each member's reading interests. When new books come in, the librarian alerts members whose interests match those books. For example, long-term member Sue Dokes, I think that's how you pronounce it, is interested in reading Western novels, growing orchards, and baking bread. There must be some way to match your interests with available books. One complication is that although the librarian wants to track all of the members' reading interests, she wants to classify each book as being in just one category of interest. For example, the classic gardening book, Orchards of France, would be classified as a book about orchards or a book about France, but not both. Okay? So yeah, read all those details and maybe read it several times so you have it in mind. So, but the most important thing that emerges from item number 3 is that you need to have an entity called interest. Okay? And each member may have many interests, right? So you can call it interest or subject. Let's call it subject. I think it's a better word because interest means a lot of things. So subject, right? So one member can have zero many subjects that he or she is interested in, and one subject can be of interest to many members. So it's a many-to-many relationship. And by the way, I'll put subject name because there will be no duplicates, right, as the primary key here. So it's a many-to-many relationship, so we need to have an associative entity in between. So we'll put an associative entity here, and it will be called member interest or member subject. Let's put interest because it sounds it sounds like as a better linguistic label because it's clear what we store here. We store information about members' interests. Member interest because it's a singular noun. The convention is to use singular nouns. So look, this member interest entity would have a compound primary key. Again, it's a primary key, and you know, it will have two parts. The first part, use dot notation, will be member ID, and you can mark it as a foreign key, although it's probably not necessary. It's clear that it belongs to another entity. And then the second part will be subject name. Again, you can mark it as a foreign key. So you see this this part of the primary key comes from this entity. This part of the primary key comes from this entity. And this is how you know that this is an associative entity. So you don't have to put any diamond here as it was described in slides. Okay. So basically it means like whenever there's a transaction between those two entities, it's recorded here. So for example, John said, I'm interested in gardening. So we make a record, John gardening, right? We put John's ID, gardening. Then John says, I'm also interested in historical novels. So we put John, again, historical novels. So we make two entries. This is to resolve this many-to-many relationship and to link those tables properly together. Okay. So if that's the case, then member interest will be like one declaration, one record will be for exactly one member. However, one member can have zero or many interests. The same thing here. One declaration of interest is for exactly one subject. However, one subject can be declared as a member's interest many times. Okay, zero many times. So it's one here, zero many here. So we need something that looks like this, right? So each declaration is for exactly one subject. So we put it here. And one subject can be declared zero many times. We'll just connect it here properly. It needs to turn green to be connected. And then I'll just straighten it out so it looks nicer. Okay. And by the way, we need the same kind of cardinality line for this relationship. So it will be one on this side. Sorry. And many on this side. Yeah, so it's connected properly. Okay. By the way, there is a trick. If you want to add more attributes, you need to click on the last row and then you click here. So that's how you add additional rows or attributes. By the way, this one was not properly connected. I connected it to the attribute somehow. It needs to be connected. To the box itself. Yeah, make sure it's connected to the box. For some reason, it's not appearing here. Like one of those connector lines. Yeah. So I'll just put it here for now because I don't see how it's being connected. Something. But again, the connection is not to an attribute, it's to an entity. Yeah, like this, yeah. For some reason I don't see this green toggle point. And I'll change the layout a little bit to make it better visible. More visible. Yeah, I'll trying to align entities. Okay. So yeah. So Did I just delete it? Or yeah, I think I deleted it. So let me put it again. Oh yeah, no, sorry, it's right here. So yeah, I'll just rearrange it a little bit like this. So yeah, you have subject being linked to members through this associative entity. But remember, it was also mentioned that books are classified into one subject. In that case, one book, and let's say here we have book ID. I know like in libraries commonly they use ISBN codes to identify books, but you see like ISBN means like one book. So for example, you can have several copies of the same book. So you still need to have some kind of book ID, book barcode, I guess. So book is classified into exactly one subject. However, one subject can contain many books. Zero books means like, let's say it's a new trend, new subject, and you haven't bought as a library books for it yet. So it's many on this side and one on this side. So you need this. So one book is classified into exactly one subject. Yeah, now I found this dot. And the subject can contain many books, and I straighten it out to make it look nicer. Okay. So this is your diagram. So book ID is the primary key. Again, I'm not going to enter any other attributes, but again, you still need to worry about foreign keys, right? So in this case, since this is the parent entity, this is a child, because in a one-to-many relationship, parent is always on the one side, child is on the many side. So you need to take this attribute and you need to insert it here as a foreign key. The same thing here. We forgot that this is a one-to-many relationship, so this is a parent entity, this is a child entity. So you need to take this key and insert it here as a foreign key. Okay, so this is how you do it. You go one by one, and you add entities and attributes. Also, you'll need to entity to store information about employees. Now, the case also says that employees can be of certain type. They can be salaried employees or hourly employees. So you need to figure out how to store all this data by creating entities and attributes. Okay. Now, when you create this model, make sure you save it from time to time in XML format so you don't lose your work. Okay. You can also save it in different locations. Now, at the end, once you're done, what you will do, you go to File and then Export as Image. So it says like, yeah, you use zoom of 100%. Don't worry if your image will be like, if you have to like somehow, resize it, because I will open it on my monitor. I should be able to see it. So, so yeah, you'll save it like this. So you press export. Let's say you'll download this image and you'll call it assignment 3 diagram. So you download it, so it goes right here. Now I'll just open this image, and so you see it's a PNG file, and I'll save a copy on my desktop just to show you how to find it later. Yeah, so I just save it to my desktop. Okay. And then, once you're done with this part one, once you have a full attributed data model and it's normalized, you just insert it here. You go to Insert, Pictures, Desktop, assignment 3 diagram right here. Okay, so you're done. And again, don't worry if it's small, you may resize it. Maybe you may want to change the layout of this assignment file to landscape so that your model fits better. But again, don't worry about the size, if you have resized it like that to make it fit on the page. As long as you have like a clear image, high definition image, I will open it on my monitor and I'll be able to grade it and put some comments in here. Okay. So yeah, that's how you do it. Again, follow the instruction. Please don't forget about the instructions, like enter your information here, save your file properly, and then submit it through Canvas. But don't forget to normalize your model, but this is covered in a different lecture. It's a part of this general discussion on database design. It's in one of those videos. I believe it's like the last part of that lecture that is also available to Integrity. So that's it. You need to do the rest of the work by identifying the rest of the entities, other attributes that belong to those entities, and also figuring out the relationships and also normalizing the diagram. So this was more like to show you the technicalities of doing assignment 3. So thank you for listening.